All right, so in this next video, we're going to talk about reading data and how to talk about it, how to describe it, and stuff like that. And so in general, we have different types of variables, and variables just means the characteristics that are being recorded or measured. So like, for example, later on, we're going to do an example over here where we're going to talk about, what's the gender, the credits, the award, the siblings. These are all variables. All variables down here that we're going to be talking about. Okay. And so all these variables have different types. They're all different types of variables. Some of the variables are numbers. Some of the variables are words. And so we're going to start by kind of categorizing these variables. So if we do that, all variables is starting at the top. And then once we proceed down from all variables, right, there are numerical variables and categorical variables. Let's start talking about numerical data variables. So unfortunately, numerical variables are not just, I solved my problem. Numerical variables are not just numbers. So it's not always as simple as numbers. That's right, not just. And I'll mention this earlier. This is an initial side note. We'll clarify what that means. But all numerical data is numbers. So these are going to be numbers, but specifically, here's a better way of phrasing this actually. Specifically, this is going to be numbers where algebraic operations are meaningful. So we're adding and subtracting means something, which is kind of a weird thing to say. Just pause a moment and we'll just take that definition for now. And then let's look at two kinds, continuous and discrete. Okay, so for continuous is like 1, 2, everything in between. Okay, it's a range with everything in between. 1.5, 1.221537, or whatever. Okay, so a continuous graph a lot of times will look like this. This is an example of a continuous graph. Intervals. Some examples of this are going to be like height. Right? Maybe I'm 6'5", maybe I'm 6'5 and a quarter. Neither of those are true, but maybe I'm 6'5 and 2/10 of an inch. All right. Weight is another one, etc. Okay. And then discrete is different because discrete is just a select few points. So this is an example of a discrete graph. It only has points, but there are gaps in the middle. Okay. So an example of discrete would be like how many eyes you have. All right, you're not going to have probably half an eye. That's a really weird example, but that's the one that came into my head. How many televisions you own, right? A lot of times it's counting. All right, how many X or something like that. Okay, how many fire stations are there in the city, for example? Okay, a lot of times it has to do with counting, and then there's no nothing in between, right? So a lot of times there's no decimals, so it's often integers, and usually positive integers. Okay, so that's numerical data. Numerical data is numbers. But some numbers can also be categorical data, which is where it gets a little confusing. So if we go into categorical data over here, let's have categorical data be green. A lot of times these are words, descriptions, kind of everything else is a good way of thinking about it. But then be careful because it's also sometimes numbers as well. Numbers can be both. All right, so that's the warning. Numbers can be either numerical or categorical, but if it's not a number, it's categorical. Okay, so regular categorical, let's pause with that because that's another everything else kind of definition. Ordinal has to do with ratings or something that can be ordered. Okay, so these are the ones that can be numbers. Okay, like how many stars would you rate this? 1, 2, 3, 4, or 5? Okay, or you know, just ratings in general. So like GPA is an example right here. Ratings is another one. How satisfied you are, right? Because these can all be ordered. Ordinal can be ordered. So just be very careful, right? This one, I'm going to write this in red. These can be numbers. So watch out. If you have a number, it's either numerical or ordinal. So be very careful when the numbers pop up. If it's not a number, then it's always going to be categorical. Okay. Identifier is usually just how are we identifying this person? This can be maybe an ID. This could be a name. This could be well, this could technically be a number too, right? Maybe we're identifying by phone number or something, but oh no. Okay. Everything's fine. Everything's fine. I erased everything, but we've got it back. That's maybe a little bit less common, but things that we use to identify somebody with are called identifier variables. Okay. And then again, regular categorical is kind of another everything else. All right. So maybe this is a description. Maybe this is, you know, gender. Maybe this is hair color. Whatever. A lot of times just kind of other things. Okay. So the cases of data or data, depending on what day I'm saying the word, the cases of data are the respondents, participants, subjects, or experimental units that are being asked or measured. Okay. Cases are the things being measured. A lot of times it's people. Okay. A lot of times we do experiments. Starting to sound like a mad scientist or something. A lot of times we do human experiments. Individuals, okay, is very, very often. Okay, these are the very common ones up here, but it can also be like a machine or something like that. Okay, this is basically who or what is being in the survey. We should switch back to blue. All right, and then the variables are the characteristics or things that are being recorded or measured. Okay, these are going to be the descriptions or something, the values. Descriptions or values right here. All right, so let's do an example. Let's kind of work with this and see what it looks like. So use the data below to explore the ideas of cases and variables with survey results from 10 statistics students. So the questions are unfortunately on the next page. The questions are on the next page. All right. And so what we have here is starting off, what are the cases of the data? All right. So then what we're going to do is say, all right, what the heck was cases? I don't remember what cases means. So we check the definition. We go over here, cases, who or what. All right. The respondents, participants, subjects, or experimental units that are being asked or measured. So when it's asking us, okay, what are the cases? That's saying who, what are the things, or who are the things, who are the people that we're measuring? Well, 10 statistics students. So the cases are the stat students. You. I'm really going into the full evil scientist mode right here. All right. They're people. Okay. What are the variables? So again, let's go back and check the variables definition. Variables are the characteristics or measurements. Okay, so variables are all the things that are being measured, or the characteristics. So ID, gender, credits, award, siblings. Oh my word, there's too many. Literally everything up here is a variable. Okay, so we could write all of that down. You could copy that. Well, we're gonna have to copy it down eventually because we're gonna have to describe it. So let's just copy it down now. ID, gender, credits, award, siblings, TV, school rating, and pulse. A lot of questions we're asking these statistics students. And at the very end, we take their pulse. All right. And then so part C is asking, describe all of these as categorical and numerical. So again, if it's not a number, it's immediately categorical. So right here, these right here are immediately categorical because they're words. Okay, so gender and award are categorical. All right, and specifically, here, I'll change colors a little bit. Specifically, you know, what are these? Well, it depends on what kind, right? Gender, well, there's three options for categorical variables, right? There's three options. An identifier, ordinal, or regular categorical. So we'll start with identifier. Right off the bat, this can't be our identifier variable because there are multiple people with the same response, right? If this is how we identify people, how we pick out which respondent is which, and they have the same one, that's not useful for identification, right? If we have the same ID cards, that's not a useful thing. So it's not going to be able to be an identifier variable. They can't be ordered. Like you can choose an arbitrary order, like alphabetical or whatever, but they aren't inherently ordinal. So that's just going to be regular categorical on this one. Okay. So categorical, regular. And then award, you can go through the same process. It's not an identifier. It's not ordinal. It's also regular. Okay. And then we can go through all of these in the same fashion. All right. Let's start with ID. So ID is a number, but not all numbers are numerical. Specifically, ID, this is how, oh, look at right there. ID is how we're identifying them. So this is a categorical variable. That's an identifier. All right. Credits. How many credits they're taking. This is going to be numerical because it's not ordinal. It's not a rating or anything like that. These are numbers that have meaningful values, right? If I'm taking 3 credits and I take 4 more, I have 7 credits now. These are numbers that make sense to add and subtract. Another thing that would not be a numerical thing would be zip code, right? It doesn't make any sense to add or subtract our zip codes or area codes or something. So even though those are numbers, those wouldn't be numerical. This right here is going to be numerical. Is it continuous or discrete? Well, you can't take 3.1 credits. So it's only 3 or 4 or 5, etc. So it's going to be discrete. I guess it depends on the institution, right? Next up is siblings. That's a number. Do adding or subtracting make sense? If I have one sibling and I add 4 more, I have 5 siblings. Yeah. And again, it's going to be discrete. So we are not going to have 2.5 siblings. I mean, we say half brother or half sister, but that's not what we're talking about here. Okay. This is discrete. All right. TV. It's a number. Can we add, does adding or subtracting these numbers make sense? I have one TV. I got another TV, and now I have 2 TVs. Okay. So yeah, this is also going to be numerical, no fractional TVs. It's going to be discrete. School rating. This is a number. All right. If I gave this school a 5 out of 5 and you gave this school a 5 out of 5, then together they have a 10 out of 5. No. Adding or subtracting ratings doesn't really make sense in this context. Okay, it's a rating. Again, another thing to look for. All right, I went a little overboard with the circling, but rating a lot of times means ordinal. Okay, so this is categorical and it's ordinal. And if you have more questions about these, because it's kind of a fine line, let me know. And then last but not least, pulse. Pulse is a number, it's a value. It is not ordinal. You can add or subtract. The numbers have meaningful differences between them. Okay, so pulse is also going to be, would we say pulse is continuous or discrete? I would say normally that your pulse is continuous, because you can have like 68.5 beats per minute, depending on, I guess it depends on how you're measuring it, right? I could see it either way. But either way, it is numerical. And let's say, I'll take either answer, depending on how it's being measured. Usually we'll think of pulse as discrete. All right. And that is the end of the notes, as I scroll up to verify that it is indeed the end of this section. All right. Let me know if you have questions.